Hello and welcome. Let's jump right into this polynomials test review with some classifying polynomials. Number one, I'm going to classify based off of its biggest exponent and its number of terms. So the biggest exponent is a 5, which makes this a quintic. And I count 4 terms, so we'll just say of 4 terms. Next, I need to state its end behavior. Again, I look at the biggest exponent. It is 5, which I care that that is odd. And I look at the leading coefficient, which is negative. Negative tells me that this will finish down, and odd tells me that the end behaviors won't match. So the only way to make that work is to make this an up-down. So something looks a little bit like this. Or there we go. And it would cross the y-axis at -1. And if we wanted to find its x-intercepts, we'd have to do some factoring and other techniques. Write a polynomial function of least degree with integral coefficients that has the given zeros. So first thing I'm going to do with a problem like this is write in the roots that have to be there based off of conjugate theorem. If we ever have irrational roots like this root 3 or imaginary like this -3i, you have to include their conjugates, or else you'll never get integral or integer coefficients. Going to apply some factor theorem here, which states that if I know the root, I can just flip it and then add it to an x to get a factor. So if there's a root at -3/4, x plus 3/4 must be a factor. Same with these other two. Plus the square root of 3, there we go. Now this one with the fraction, if I just distributed this out, it would keep that fraction. I want integer coefficients, so I can get rid of this fraction without changing where the root is by just multiplying both the x and the fraction by its denominator. This gets me a 4x plus 3. Notice this does change the function, but it doesn't change where its 0 is. I could still set this equal to 0 and solve. You can see the 0 remains at -3/4. And that's my whole goal, is just getting the correct 0. So I don't care that I've maybe made this function a little bit steeper. I've vertically stretched it by a factor of 4, as long as I get integer coefficients. Let me go ahead and FOIL my conjugates over here and see what happens. I get an x squared plus the square root of 3x minus the square root of 3x, and then -√3 times a positive root 3 is -√3 squared. The square root and the squared cancel out. That's just a -3. Also, these terms cancel out since they're exact opposites. Let's see what we've got left. I've still got this 4x plus 3. But now this over here is collapsed to x squared minus 3. Let's FOIL this and we'll get our final answer of 4x cubed plus 3x squared minus 12x minus 9. Put a box around it. There you go. For number 3. Number 4 would be very similar, but just make sure to include positive 3i as a root and multiply this one by a 3 to the whole factor, including the x. All right, simplify. We'll start with number 6. Looks to be a little bit more tricky. I start by foiling these first two imaginary numbers. But when I am doing imaginary number arithmetic, I just have to remember, if I ever get an I squared, I'm going to immediately replace it with a -1. All right, with that being said, let's do this distribution. 7 times -4 is -28. 7 times a positive 7i is positive 49i. -7i times a -4i, negative times a negative is a positive 28i. And -7i times a positive 7i. Well, the -7 times the positive 7 is a -49, but the I times the I is an I squared, so I'll immediately replace that with a -1, which will make this whole thing a positive 49. Let's go ahead and combine our last terms. These will combine to be a 21 plus 77i. Now I just have to do that exact same process with another imaginary number and simplify from there. First, 21 times -5 is -105. Outside gives me a negative 84i. Inside, let me see, I'm going to do that in my calculator. 77 times 5 is 305, so negative 305i. And last, gotta do that on my calculator as well. 77 times 4 is, oh, I read that number wrong earlier. This was a 385. And now this is a 308. Negative 308i squared, making this whole thing actually a positive 308. Combine all of our like terms, 308 minus 105 gives us a 203. And the negative 84 minus 385 gives us a negative 469i. All right, let's look at some of these fractions. Let me make that box a little better. When I'm trying to simplify a fraction, it's got an imaginary number in the denominator. I have to multiply that denominator by its conjugate. Do number 7 here. The conjugate of negative 6 minus 3i would be negative 6 plus 3i. But whatever I do to the top or the bottom, I must do to the top. So let me add another negative 6 plus 3i to the top. Add in a whole bunch more parentheses to help kind of simplify this and what we're doing. And now I just have to FOIL the top and then FOIL the bottom. Let's FOIL the top. I'm going to get a 42 minus 21i plus 36i minus 18i squared. FOIL the bottom, 36, and here's where the power of the conjugate comes in, because I'll get a minus 18i plus 18i when I do the outside and then the inside. And then negative 3 times a positive 3 is a negative 9i squared, makes this a positive 9. And that I squared up there makes this a positive 18. And I'm going to go ahead and cancel out these terms that cancel. Next, I need to combine my like terms. 42 plus 18 is 60. 36 minus 21 is 15, so plus 15i. These have common factors, so there's a potential to simplify more. Let's see what we get on the bottom. 36 plus 9 is a 45. Yep, lots of opportunities to simplify. Let's divide everything by 15 on the top and the bottom. More parentheses to just make sure we do this right. 4 plus I over 3. Let's see if we got number 7 right. 4 plus I over 3. Yep, looks good. I think we'll call that good for the front page. Moving on to page 2. Time to practice. It says divide, practice long division, and double check with synthetic. Let's do that with, I guess, number 9. Looks like it might have slightly worse coefficients, not by a whole lot. Let's do the long division. I'm going to have to write small here to get this to all fit. X plus 8 divided into x to the 5th plus 14 x to the 4th plus 39x cubed minus 67x squared plus 30x minus 80. No way I'm able to fit all this in. Why don't I just... Now I can fit it all. All right, first thing, I just focus on the biggest term, which is just an x. To get an x to fit into an x to the 5th, I just have to multiply by x to the 4th. Then I actually do that multiplication. I get my x to the 5th, but I pick up an extra 8x to the 4th. Subtract that away, and we're going to get 6x to the 4th, drop down the next term, plus 39x cubed. How do I get an x to fit into a 6x to the 4th? Well, a 6x cubed will do the trick, actually do the multiplication, and get a 6x to the 4th, and I get a plus 48x cubed. Subtract it away. 39 minus 48 is a negative 9x cubed. Drop down the next one, negative 67x squared. How do I fit an x into that? Well, negative 9x squared. Actually do the multiplication, negative 9x cubed minus 72x squared. Parentheses are your friends, subtract it away. Negative 67 minus a negative 72 is the same as negative 67 plus 72 for a total of 5x squared. Drop down the next one, which is a 30x. How do I fit an x into a 5x squared? Well, with a 5x, actually do the multiplication. We get our 5x squared back. We get our plus 40x. Subtracted away, negative 10x minus 80. How do I fit that in? Negative 10 times. It's worthwhile to just show that this would give us 0 remainder. It's a good way to double check we did it right if we were expecting it to fit in evenly, which I guess we weren't expecting it to fit evenly, but I was nice. And if it fits in evenly, it's a good sign. Let's double check this with synthetic now. My coefficients, 1, 14, 39, negative 67, 30, negative 80. I'm going to synthetically divide this not with a positive 8, but with a negative 8. We divide with where the root is, not with the factor. 1, negative 8, 6, negative 48. The extra perceptive student will notice we're doing a lot of the same arithmetic that we did over here, like 39 plus 40, minus 48 is a negative 9, 72, 5, negative 40, negative 10, 80, 0, and this gives us the same coefficient that we see up there. 1x to the fourth plus 6x cubed minus 9x squared plus 5x minus 10. All right, so we did the long division, we double checked with synthetic. Let's move on to number, we'll go 12. When it's odd, it makes things just maybe slightly more difficult. Complex zeros. So complex, fundamental theorem of algebra states that there are a total of 3 zeros and all numbers are complex, including the imaginary ones, so complex 3. Real, well, for this we kind of have to pair them off. It could be 0 imaginary, 3 real. It could also be 2 imaginary and 1 real. This is because the imaginaries have to come in pairs, and when we add them together, they have to add up to 3. So possibilities for the real were 1 and 3, and possibilities for imaginary were 0 and 2. These will always come in pairs. I couldn't go up to 4 imaginary because then I'd be exceeding the 3 complex zeros. All right, rational roots. I need to find the factors of my last. Numbers that divide into 25 evenly, that's 1, 5, and 25. And factors of my first, well, that's just a 1. All the factors that I can make last over first is going to be 1 over 1, 5 over 1, and 25 over 1. And I just need to slap a plus or minus in front of that, and that's my list of rational roots. Yes, these could all be simplified to just 1, 5, and 25. All right. State the possible rational zeros for each function, then find all zeros. There is a multiplicity, give you a big hint here. So let's list out the factors of the last is just 1. The factors of the first is just 1 and 2. So my list would be 1 over 1 and 1 over 2, plus or minus. So let me list that fully out. 1, 1/2, negative 1, negative 1/2. So these are the numbers I need to test with synthetic division. Let's start with the top row here of synthetic division. Careful if they ever skip a term, you need to put it in 0. Let's check it with 1. 2, 2, -3, -3, 1, 1, 0. So 1 is a root, but if it is a double root, it will work again if I use this bottom row. So 2, -3, 1. Put a 1 here, so we got 2, 2, -1, -1, 0. Yes, 1 was a double zero, so we'll write yes on both of these. I did not mean to accidentally find it on my first guess, but I guess I had a 1 out of 4 chance, and I always start with the easiest integer. Fundamental theorem of algebra predicts 3 roots. The remaining root can't be, I'll do 2 check marks, irrational, so it's got to be one of these. So let's just keep checking them until we find the remaining root. 2, -5, 4, -1. Let's test it with a half. So 2, 1, -4, -2, 2, 1, and I guess you just get lucky sometimes. That was the remaining root. I seriously just guessed, but I wanted to do the positive numbers first. Let's see if I even got that right. Also, how would we write this? We would say 1 molt 2, comma 1/2. That's our full answer right there. Let's just check it with one that's not a root, just to prove that if we had done one of these, we wouldn't have gotten a 0. In case you just think, wow, you always get a 0. Let's try -1. So 2, -2, -7, 7, 11, -11, -12. So this was a no. This was a yes. All right. And -1/2 won't work either. All right. Those are our big problems. Factor each and find all roots. One root has been given. Do we want to do the imaginary one? Do we want to do the rational one? This one's to the 5th degree. This one's to the 4th. I guess I'm going to do the 5th degree one. Although this square root of 39 looks a little bit scary. Just remember when you do the square root of 39 times the negative square root of 39, that's just a -39. So 14 should be okay. Let's do 15. All right. We know we're going to have 5 roots. There's one of them. We get that one for free. Or we're just given that one, and we get another one for free. The one that we get for free is -2 minus 4i, its conjugate. Now I need to actually multiply the factors correlated to these together to get a quadratic factor of this quintic. That'll make sense here in just a second. So I can do x minus 2 plus 4i times x minus 2 minus 4i. So these are the factors related to these two roots. Just using factor theorem, let's distribute them. X squared minus 2x minus 4ix minus 2x plus 4 plus 8i plus 4ix minus 8i. 4 times -4 is -16 I squared. This here is going to become a positive 16. This is going to cancel with this. This is going to cancel with this. All together it becomes x squared minus 4x plus 20. There's my quadratic factor. Now I need to long divide this into this guy up here. So x to the 5th plus 4x to the 4th plus 11x cubed minus 36x squared minus 180x. Oh, we missed wasn't paying attention, we can actually factor an x out of this, divide everything by x. We're not really dividing everything by x, but we're taking an x out, and that's going to give us another root at 0 because one of our factors is just x. And then I can reduce everything here by 1 degree. Didn't even notice that. And life's a little bit easier. So this is x to the 4th, 4x to the 3rd, x squared, minus 36x minus 180. Let's divide in this quadratic factor. What do I multiply x squared by getting x to the 4th? Well, that's just an x squared. Actually do the multiplication, we get an x to the 4th minus 4x cubed plus 20x squared. Parentheses, subtraction, these cancel. Negative 4 minus a negative 4. Careful, that's not 0. That's 8x cubed. 11 minus 20 is negative 9x squared. Drop down the next term, negative 36x. What do I multiply x squared by to get a negative 8x cubed? Well, positive 8x. Actually do the multiplication. 8x cubed minus 32x squared plus 160x. Parentheses, subtract negative 9 minus a negative 32. So negative 9 plus 32 is 23x squared. Negative 36 minus 160 is negative 196x. Drop down the last term. Hoping this is going to work out. The next one's got to be a 23 to get a 23x squared. Negative 4 times 23 is negative 92. It's concerning me because that's not going to give me 0 remainder. Just give me a second here to spot my mistake. I'll look all the way over here just to make sure I did this distribution right. I get a negative 2x. I get negative 2x. You get a positive 4 and then positive. So I think that's right. Let's see. X squared times that gives me that. X squared times that gives me that. Subtract, drop the 36. 8, negative 32. Right. And then 160. 23, negative 169, negative 180, and 23 times 20. That's way out. That's 460. Oh, bear with me here. I will see my mistake in. Oh man, it's way back here. Because when you use factor theorem, you subtract these. So these should be positive 2's. I tried to do that distribution in my head, and now it's really going to bite me because this should be a positive 4x. This is still a 20, so let's just see if that's a positive 4x there. Maybe it's not a total disaster. Okay, so this would be, so it's going to end up as, okay, so these do cancel. Okay, let me erase from here. These do cancel. These become a negative 9x squared. This is just a drop down the negative 36x, then the minus 180. I multiply now by a -9. Let's actually do that multiplication. -9x squared minus 36x minus 180. There's my zero remainder. It was actually a lot easier if you do it the right way. Here's my remaining quadratic. X squared minus 9 equals 0. This is very easy to solve. We just add 9 to both sides. X squared equals 9. Take the square root, take the square root. X equals plus or minus 3. So let's see if we got all the roots for 15. 0, -3, +3, -2 plus 4i, -2 minus 4i. All right, so yeah, this is what I shortcutted here. I should take these factors and write them as x minus -2 plus 4i and x minus -2 minus 4i, and then that negative should have become a positive here. Tried to skip that. It really cost me. This wasn't that long a problem if you do it right, actually. All right. Well, we're going to recover from that. Thanks for sticking with me. First 8 rows of Pascal's triangle. To form Pascal's triangle, you start with a 1, and then you just keep adding 1s down the diagonal. And then to get the interior numbers, you just add the 2 numbers above it. And we got to get to 8 rows here. So we're almost there. We'll know the first 8 rows. Technically, it doesn't say to the 8th row, because that would be one more row than this. Since the 8th row is called the 7th row, we'll just do the next one. 28, 56, 70, 56, 28, 7, 1. Next, all right. So finally, some binomial expansion. Let's see, we'll just pick one. Number 21 looks kind of tricky because it's got 2 different variables. There's a minus, it's to the 4th. First thing that we're going to do, after creating a little bit of space over, is I'm going to expand the generic form a plus b to the 4th. This is, to do this, I need the 4th row of Pascal's triangle, 1, 4, 6, 4, 1. And then I fill it in with a's in descending order, so a to the 4th, a cubed, a squared, a, no a's, and then b's in ascending order, so no b's, b to the 1st, b squared, b to the 3rd, b to the 4th. So that's my generic expansion of a plus b to the 4th. Now I just want the second term, and I need to define what a and b are. A is x, b is equal to -3y. Plug those in for a and b. Let me write it out one more time. 4a to the 3rd b is going to equal 4 times x to the 3rd times -3y. I like to get this into alphabetical order. That -3 and that 4 are going to combine to be -12. So it's going to be -12 x cubed y. -12 x cubed y. Let's see if that's right for 21. Yep. And let's do a binomial expansion way out. Pick 25 looks pretty tricky. First, I need to get the generic form of just a plus b to the 5th. I'm going to try to do this just in one go. So I've got 1a to the 5th plus 5a to the 4th b plus, I believe it's 10 a cubed b squared plus 10a squared b cubed plus 5a b to the 4th plus 1b to the 5th. A here is equal to 1, b is equal to -3v. Let's plug all those in. It's going to give me things in kind of reverse order. You could flip them now. since you know that you're going to end up flipping them all at the end, but I'll leave them in this order and then flip them all later. So this 1 to the 5th is just 1, so this first one's just 1, plus 1 to the 4th is just 1, so this is 5 times negative 3v, plus 10, that's just 1, negative 3v squared, plus 10, that's 1, negative 3v to the 3rd, plus 5, negative 3v to the 4th, plus negative 3v to the 5th. Simplifying, I've got 1 minus 15v minus, okay, so this squared gets applied to the 3, which makes it a positive 9. So this becomes a plus 90v squared, plus negative 3 cubed is negative 27, so really minus 270v. Negative 3 to the 4th, that's positive 81 times 5. It's 405. Oh, this should have been a v cubed, so 405. V to the 4th. And then negative 3 to the 5th. Parentheses, negative 3 to the 5th. Negative 243. V to the 5th, and now I'm inclined to put this in standard form. I think the answer key might look like this. Yeah, the answer key doesn't have it flipped around yet, but I'm inclined to put that into standard form. Descending order of exponents, so negative 243 v to the 5th, plus 405 v to the 4th, minus 270 v cubed, plus 90v squared minus 15v plus 1. I like that better in standard form, but however you want to do it. All right, that's that for this homework help video. Hopefully you found that useful. Check out the other videos for more individualized help on the different parts. Just use this to get started, and have